After system identification, our Dexterous hand has essentially zero Sim2Real gap. You can see our engineers ran these curves. We found that the Sim2Real curves and the actual curves are completely matching. This means you can get a system in simulation that closely approximates the real physical state of our Dexterous hand. The idea that direct drive Dexterous hand generate too much heat is somewhat of a misconception. Let me give you an example. Server GPU cooling can reach power densities of even kilowatts per square centimeter. But actually that power level is 2 to 3 orders of magnitude higher than what a Dexterous hand produces, which means the cooling requirements for Dexterous hand really aren't that demanding. I believe the Dexterous hand itself doesn't need too many sensors. Right now, the industry is still in its early stages, so we have some transitional tactile solutions on the Dexterous hand, but I believe in the end state it won't need them. Having all the sensors on the glove will be sufficient. I'm a believer that large models can solve everything. With enough data, large models can enable a Dexterous hand to do things even with zero shot. So I think all these clever tricks and constructs are insignificant in the face of massive amounts of data.
Hello everyone, and welcome to this episode of the podcast co-produced by the Alphaist and Wuji's Talk. I'm Peter Chen from Alphaist Partners, a venture fund focused on hard tech. Our mission is to empower alpha founders and propel humanity forward. The Alphaist is a deep dive conversation series exploring the first principles of tech and entrepreneurship, featuring early stage founders, engineers, and product explorers who are changing the world.
Hi everyone, I'm Yunzhe Pan, the founder of Wuji Technology. Founded in 2019, Wuji Tech began with high torque density motors and has grown into a global leader in high-DOF Dexterous hand and data acquisition systems, delivering world-class general-purpose manipulation solutions. Wuji's Talk is a podcast by Wuji Technology, connecting industry professionals and researchers to share insights and explore the future of technology.
Over the past year, embodied intelligence has been one of the hottest areas in the entire tech industry. But if we look closely at all those cool videos, we'll find that most robots are doing whole-body movements like dancing or boxing, or relatively simple grasping and carrying tasks. Truly fine manipulation tasks are still very rare. The reason is simple. The leg problem has been mostly solved, but the hand problem is far from solved. The Dexterous hand is the last mile of embodied intelligence. Without a sufficiently dexterous and reliable hand, robots cannot truly enter widespread application scenarios. So today we're focusing on Dexterous hand. We're honored to have Yunzhe Pan to talk about his entrepreneurial journey and insights on Dexterous hand. First, let me ask Yunzhe to briefly introduce himself.
Sure, I was born in 1995 and graduated from UIUC in 2018 with degrees in computer science and chemistry. I started my business right after graduation and founded Wuji Tech in 2019. For the first 4 years, we focused on high torque density motors for humanoid and quadruped robots. At the end of 2023, we pivoted to making Dexterous hand the most important component in humanoid robots.
First, congratulations on the release of Wuji hand in September 2025. The performance amazed the entire market. As you mentioned, the company only started working on Dexterous hand at the end of 2023, having focused on motors before that. Going from zero to product release in just over a year is incredibly fast. Can you talk about the motivation for pivoting from motors to Dexterous hand? What opportunity did you see that made you feel you had to enter the market?
Actually, I've never mentioned this publicly before, but back in 2018, I tried making a Dexterous hand at home. The performance was just terrible. The supply chain and technology were both very immature at the time. So after finishing the prototype, I didn't continue, because I felt I couldn't make anything meaningful out of it. But Dexterous hand have always been a direction I'm very interested in. By the end of 2023, there were several reasons. First, I found that when I told people I ran a motor company, recruiting became extremely difficult. Top talent just wanting to do something more exciting. Second, we saw that Unitree robots were selling very well in academia, meaning the market was actually big enough, but there weren't any good Dexterous hand on the market, and the space for publishing papers on Dexterous hand was much larger than for robots. Third, at the time there were only 2 commercially available Dexterous hand that I remember, the Inspire hand from Yunzhe and the tendon-driven 22DOF Shadow hand. The former had relatively low degrees of freedom and the latter was too expensive. So the entire Dexterous hand market was a huge blank space, which is why I decided to go for it.
So at that time, what made you confident you could actually build a Dexterous hand?
I spent a long time working on motors. From 2020 to 2024, I did extensive research on materials, gearboxes, motor joints, transmissions, and robots. Our validation path was very simple. I measured the dimensions of human finger joints, then roughly sketched out a motor and gearbox transmission stack. I calculated how much torque and speed our existing motor technology could produce in that space, and found it far exceeded human capability. So we concluded that if I could fit a motor into that finger space, I could definitely make an excellent dexterous hand. I did this on my computer, and validating it took less than half a day. Then we just went ahead and built it.
So, if I understand correctly, when you chose this route and design approach, you didn't really reference or compare it much to the two main technical approaches that existed at the time, Inspire's linkage mechanism and Shadowhand's tendon-driven approach. Instead, you derive from first principles whether putting motors directly in the joints using a direct drive approach could achieve the design performance you wanted.
That's how it was. I actually already knew what paths were available for dexterous hand. I did a lot of research back in 2018. I read all the theses and papers on dexterous hand, understanding their structures and what problems they had, including the famous DRR hand and dexterous hand from the US. In 2018, I actually built a tendon-driven dexterous hand myself and discovered it had many problems. Combined with our deep know-how in motors, I naturally wanted to try a different approach.
Pivoting from the motor business to dexterous hand was still quite a big transformation. How did you convince yourself and the team at that time? Looking at the team back then, if you were going to go all in on dexterous hand, were there gaps in the team's core capabilities? How did you plan to address those issues?
Honestly, at the time, I didn't think there were that many problems. It was a bit like fearless naivety. Looking back, the team at the time was completely incapable of making dexterous hand, but I never think about problems that way. My approach is always, does this have huge potential? Is there an unsolved problem? Can our product achieve enough differentiation? Is anyone else doing the same thing? If not, then I think it's worth doing. Actually, when I was doing motors, I was very conflicted inside. Looking at motor companies, even the ones that went public, their influence in the industry, their overall state as companies. I talked to some founders of publicly listed motor companies, and I felt that reaching that level wasn't the state I wanted. If my next 5 to 10 years was going to lead me to become like them, I was very resistant to that. That was the most fundamental reason.
Let's review the development of the company's dexterous hand products. You released your first generation product at the end of 2024, and the version launched in September 2025 went through significant iteration. During this year of iteration, what were your key lessons learned?
To be precise, that wasn't the first generation. It was already the fourth. The product we released in September 2025 was actually our fifth generation. The fourth generation's problem was too large. However, size is quite important. And when we finished the fourth generation, I thought of a better configuration. So we directly applied the lessons from the fourth generation and started on the fifth. Yet there was also a problem that really troubled us before the fifth. A component had a severe reliability issue. No matter what we did, the wiring harness lifespan wouldn't exceed 1 million cycles. This problem would multiply when we went to mass production, and there was no way to control it. So I decided we needed to use a newer approach to solve this problem, which led to the concept for the next generation.
And how do you view the iteration of each generation's design? Does the starting point for each design iteration come from your own mind?
In the early stages, there wasn't a clear process, but I did have some methodology. When conceiving a solution, I would firstly list out what I thought were the challenging points, then discuss with our engineers what they thought were the high-risk areas. At the beginning of any solution, we would brainstorm. After brainstorming, we'd list out these risk points and directly research them, even making some prototypes to see if these problems really existed. This is our methodology for deciding whether to pursue a solution. The process of forming a new solution is actually quite random. Maybe I see something and think, could this be applied to our product? Then everything started.
Internally, how do you define what makes a dexterous hand a good one? The design space is huge, with so many different dimensions and metrics. How do you ultimately decide whether a hand really meets user needs and makes sense for the market?
There's already an excellent dexterous hand in this world, our own human hand. So we break down the human hand into several dimensions and benchmark against each one, including the distribution of degrees of freedom, shape, weight, size, force, speed, softness, tactile sensing, appearance, and the reliability. As a thought experiment, if you could perfectly interface the human hand's actuation and nervous systems with computation, you'd end up with an all-around system, one without major weaknesses across any of those dimensions.
You mentioned the thought experiment where the human hand serves as a reference point for your design. If we look at the anatomy of the human hand, many of the muscles that drive finger motion are actually located in the forearm. But in your design, the actuators and joints are all integrated within the palm. Why did you choose this approach, instead of a more tendon-driven forearm-actuated design that might look closer to biological hands.
I believe tendon-driven systems come with fundamental drawbacks even though they're very similar to human hand. At a very basic level, if a direct drive dexterous hand can achieve the full range of human hand functions, then there's no strong reason to take on the additional complexity of tendons. More importantly, tendon-driven designs introduce significant product-level challenges. You have to couple the hand with the forearm, which is not something many customers are comfortable adopting. For academic users in particular, especially those who already have robotic arms, what they really want is a dexterous hand they can mount directly. Second, the tendon-driven problem is that human tendons basically use 2 tendons per degree of freedom, 1 flexor and 1 extensor for extension and contraction. If you want to do this, your motors double. For example, a 22 DOF dexterous hand would require 44 motors. That's not a great solution. It creates control challenges, cost challenges, and wiring issues that make system maintainability very poor. There's another approach where you pull one side with a tendon and use a spring for forced return, but that has many problems too. You can't control the outward force on the back of the hand. That's one problem. The second problem is that spring characteristics are very hard to simulate. Simulation fundamentally wants accurate force, but with a spring as a disturbance, your force readings become very inaccurate, creating a huge Sim2Real gap. These problems aren't unsolvable, but you need the entire upstream and downstream ecosystem to solve them with you, which makes the cost very high. Third, tendon-driven systems suffer from creep over time. Tendons gradually loosen with use, which creates durability and lifetime issues. Of course, there are solutions like adding pre-tensioning mechanisms, but that brings us back to the problems I just mentioned, either 2 motors pulling or using springs.
Right, so let me summarize my understanding. We chose the direct drive approach first, from a forward design perspective. We believe direct drive can achieve the performance and the size we expect. Second, with the tendon-driven approach, since you tried it in 2018, you found that the fundamental problems require the entire industry to solve, whether it's tendon materials or newer modeling methods for compensation. Looking at the rapid iteration and development of simulation systems today, the advantages of direct drive are very obvious, and it can overcome the difficulties of scaling and the stable production that tendon-driven faces. I also often hear you mention that Wuji Tech's direct drive approach has minimal Sim2Real gap. Have we done experiments to verify this?
People doing reinforcement learning perform system identification, identifying the dexterous hand's dynamic response, its tracking performance, how good its PD control is. After that, our dexterous hand has essentially zero Sim2Real gap. You can see our engineers run curves, and we find that the sim curves and actual curves are completely matching. This means you can get a system in simulation that closely approximates the real physical state of our dexterous hand. With a small Sim2Real gap, you can capture all the variables.
Was the small Sim2Real gap an insight you had from the beginning of the design? Or did you gradually realize this advantage during the development process?
No, it wasn't. We didn't realize this on day 1 of the design. When we started making dexterous hands, Sim2Real wasn't that popular yet, at least it hadn't shown its true power in humanoid robots. Only a very small circle, the people at ETH were doing RL Sim2Real. It was only during the process that we gradually discovered, hey, this can be used for Sim2Real, and then we started optimizing specifically for Sim2Real.
So you ultimately chose a direct drive approach, with actuation integrated into each joint. Before your work, this wasn't really a mainstream direction. Why do you think the industry historically didn't go down this path?
First, actuator supply was a big bottleneck. Second, the rise of humanoid robots has been quite short, so people haven't had much time to think deeply about what approach to use. Third, humans are naturally tendon-driven, so from a biomimetic perspective, the first thought is to make dexterous hand the human way. Even when I first started making dexterous hand, I thought the same way. So going tendon-driven is a very intuitive idea, but going direct drive isn't as intuitive.
With motors embedded in each finger segment, probably the most direct issue is that these are micromotors with high power density, which generates a lot of heat during operation. How is the heat dissipated? How does your current design address thermal management?
The idea that direct drive dexterous hand generate too much heat is somewhat of a misconception. We admit our first generation product may have had some heating issues, but just like when iPhone 4 launched with antenna problems, they solved it later. From an engineering standpoint, solving this heating problem isn't particularly difficult. Let me give an example. Server GPU cooling reaches power densities of even kilowatts per square centimeter. But that power level is 2 to 3 orders of magnitude higher than a dexterous hand, which means dexterous hands don't actually have high cooling requirements. Once you have some active or better thermal management and thermal design approaches, the heating problem can be solved very easily. From a thermal perspective, it's really just three things: the heat source, heat transfer, and heat dissipation. What's the heat source? Reducing heat generation itself means improving system efficiency, and we've already made significant progress on this. Second is heat transfer. We're trying many new heat transfer methods and seeing some positive results. Third is heat dissipation, which is actually relatively simple. If you can transfer heat from the fingers to the palm or even to the wrist, since the wrist surface area is much larger than the fingers, once you can transfer the heat there, there's basically no risk of overheating. So we're actively trying and investing in all three directions, and we should see some milestone results in our next generation product.
I'm curious about your expectations. If the Dexterous hand is working under continuous high payload, what temperature range do you think is ideal?
Normal industrial products like chips have standards, say -10 to 85 Celsius degrees. So we think 85 degrees for the hottest internal temperature is a reasonable number, but this doesn't mean the external surface should be 85 degrees, because people often interact with Dexterous hand.
So from a touch perspective, it might be higher than body temperature. But from the standpoint of operating conditions, stability, and continuous heat dissipation, it can maintain at a relatively high temperature.
Right, actually your motor lubrication efficiency is higher at elevated temperatures. As long as the surface temperature isn't too high, not exceeding 45 degrees or so, it's actually quite safe.
The current Dexterous hand supports a 20 kg static grip and a 5 kg two-finger pinch. How did you settle on these numbers? Were they based on real use cases or more on design trade-offs?
Actually, when designing, I believe the force just needs to be sufficient. There's no need to pursue extremely high force. If a Dexterous hand can handle light loads, especially things that female workers on production lines can do, the market is already huge. There's no need for heavy loads at all. So from the start of our design, we didn't specifically optimize for ultra-heavy loads. The 5 kg and 20 kg figures came from after we built it. We tested whether we could lift things like that, and it could. So we said we can handle this much load. Maybe it can actually handle more, but we haven't done those tests.
How do you make trade-offs between payload, hand size, and hand weight? I noticed that a very important aspect of our first generation product is its very lightweight, around 600 grams.
The product we released at the end of 2024 weighed 85 kilograms, and at the time I absolutely couldn't accept that number. When it comes to payload, weight, and size, I think payload should be sacrificed first. Frankly, if a light load Dexterous hand can't be used, then a heavy load one definitely can't be used either. As for weight and size, I think these two are equally important. If I had to rank them, size might be slightly more important, because size means if your hand is too thick or your fingers are too fat, it sacrifices dexterity. Since these two are highly correlated, when size goes up, weight goes up too.
When designing the Dexterous hand, how do you view reliability and lifespan? Do you have internal gold standards for reliability metrics? Or what kind of cycles or working hours do you consider acceptable?
I believe reliability is the holy grail of Dexterous hand. It's the most underestimated yet most complex and difficult problem, especially for high-DOF Dexterous hand. Because the system is extremely complex with so many components, achieving high reliability is a challenge. Even a company's biggest moat. It's actually very hard to define precise standards for Dexterous hand, because the scenarios and operating conditions people use them in are extremely complex. You can't just use one test to cover all operating conditions and types. This fundamentally contradicts the versatility of Dexterous hand.
So you can't evaluate the systems using the traditional logic of industrial arms, things like repeatability or cycle counts at maximum payload. That kind of metric is just too one-dimensional.
Right, say I use a certain grip posture to lift a heavy object. Only some joints in the hand are under load, and you're testing the lifespan of those local joints, not the entire Dexterous hand system. If after lifting heavy objects, it needs to do something else, the affected components are different, so your previous test becomes meaningless or inaccurate. Industrial robotic arms are simple in that you just hang a load on the end and let it move. The worst case scenario is extending the arm horizontally and moving continuously. That's the harshest scenario for all joints. But for Dexterous hand, you can't simply use this metric to measure. Using a single test is very difficult.
When you start scaling production, how do you think about reliability from one generation to the next? Do you build that up from component level constraints, or do you look at it more from a system perspective, especially across different operating conditions? And how do you make sure reliability keeps improving and doesn't fall apart once you're shipping at scale?
I think this is a company-wide organizational system. In engineering, we see that in mature companies, quality is a separate department that reports directly to the top. A standalone quality department. Why? Because quality involves such a long process chain. It starts from product design, to product review and validation, to production, to shipping, to customer complaints. You need to consider the entire process from start to finish. From the design stage, you need to think, what problems have we encountered before? What are the failure-prone points? Then during manufacturing and procurement, you need to design strict standards. When shipping to customers, you need to continuously collect customer feedback. So it's a very systematic endeavor. As for the specific control aspect, this is usually controlled during production and manufacturing. You really can't do destructive testing on every dexterous hand you ship, right? You can use some indicators to test without destroying it. How do I ensure quality is still good? This has to be simple tests at the component or module level, not violently testing every single hand before shipping.
From your experience developing so many generations of dexterous hand, what lessons have you learned about reliability or quality?
A big lesson is that I think the reliability department should be established and deeply involved from the product design stage. I feel many companies underestimate the importance of this department or role. Actually, we've recently been building up this capability.
I'm curious, from your current perspective, if dexterous hand are to achieve large-scale industrial or commercial deployment, what key technical or engineering barriers still exist?
I believe our next generation dexterous hand should be suitable for deployment, suitable for large-scale industrial scenario deployment. But I think the biggest bottleneck right now is still algorithms, and the bottleneck for algorithms is data. There isn't actually much good data for dexterous hand modalities right now, especially for acquisition equipment. So we believe that for deployment to happen, we first need to solve the data acquisition equipment problem.
So from your perspective, our next generation dexterous hand can basically solve the hardware and mechanical issues like reliability, lifespan, and cost. The bigger challenge is how to better collect data, use that data to train better models, and enable downstream applications.
Yeah,
Do you have any thoughts on data collection methods and timeline?
I believe dexterous hands will begin large-scale deployment around 2027 because effective data acquisition systems can collect data very quickly. This is also a core direction in how we design our data acquisition equipment.
Your data collection approach is mainly through a data acquisition glove on the dexterous hand, right? Or are you also trying different technical approaches?
I believe that to collect data well, it has to be worn on the person. It shouldn't be worn on the dexterous hand, or on the robot, or have some massive or complex machine between the person and the physical world. If you want to be fast enough, the person should be the direct medium of contact with the physical world. You still need sensors, right? But that layer between the sensor and the person to the physical world should be as light and as minimal as possible. We design data acquisition with a minimalization philosophy.
So my understanding is that your data acquisition equipment is designed to be quickly deployed on the collection personnel. Making it into a glove that's fully compatible with human hands would be the simplest and most intuitive approach.
Yep.
How do you see exoskeleton-based approaches for data collection, like DexYumi and DexOp?
We've tried both DexYumi and DexOp. I think they're supplementary data solutions, but they're unlikely to become the main approach for data collection. I think they're reasonable for fine-tuning, for data needed in post-training, or as a small recipe in pre-training. But fundamentally, they can't be made very lightweight without intruding with people's daily work, so I don't think they'll become mainstream.
So, looking at the data collection pyramid, we want to use the simplest possible method, the lowest cost method, to collect large amounts of real human operation data with the lowest possible mapping cost to our dexterous hand.
Yep.
So such a data acquisition glove, I imagine, would be isomorphic to your dexterous hand's configuration, usable both on real humans and on your dexterous hand.
Yep.
Do you see glove-based sensing paired with dexterous hands as a transitional solution, or something more long-term? Looking ahead, do you expect tactile sensing to move increasingly onto the hand itself, or will gloves continue to play a role?
I believe in the end state, the glove is the only solution. I don't think the dexterous hand itself needs many sensors. But because the industry is still in its early stages, we'll have some transitional tactile solutions on the dexterous hand. But I believe in the end, having all the sensors on the glove will be sufficient.
This is quite a unique perspective we're hearing, because many companies are continuously adding sensors to the hand.
Right, but you can't solve the data source problem. It has no value, no ultimate value.
What's your approach to force control on the dexterous hand? Are we directly using current feedback to sense force control?
Yep.
Can tendon-driven systems solve force sensing on their own?
No way, not at all.
That should be quite difficult, right? Because the tendon-driven force can't be sensed and transmitted back. It's not like a motor.
That's right. For tendon-driven systems, there are a few approaches. There are two methods. The first is having tendons on both sides, both with motors pulling, so you can calculate the difference between the two motors pulling forces. The second is using springs, but that has problems because you don't know how much the spring has deformed. Or even if you know, you have to subtract the spring force from the motor force to get the finger force, which introduces another layer of error. And if you try to read the tendon-driven force from the motor side, linear joints generally have very inaccurate force readings, extremely inaccurate, because lead screw mechanisms inherently have significant losses. The second approach is adding a tension sensor on top, but I haven't seen any company present such a solution, though some do try this, but from a simulation perspective, force sensors aren't very easy to simulate. In Isaac Sim, it's unnatural within the workflow and requires processing that's actually quite difficult.
If we think from first principles and take collaborative arms as an example, a lot of force-controlled cobots use strain gauges because relying only on motor current gives you fairly rough force estimates. But in a direct drive dexterous hand where you have many actuators and much more delicate force interactions, do you think current sensing alone can really support fine force perception?
Yes, there's no fundamental challenge. Collaborative arms can't achieve particularly good pure current-based force control comes down to several factors. First, the motors are very large, which means large motor inertia, and inertia plays a very significant role here. Second, the gear ratio is also very high. They typically use harmonic drives with a 101 ratio. Motor inertia's effect on force control gets multiplied by the square of the gear ratio, so if the ratio is 100, you're dealing with effectively 10,000 times the inertia. There's no way to achieve particularly good force control. But dexterous hand motors are different. Their inertia is very small and naturally much easier to achieve good force control.
There are more and more players in the dexterous hand space with very different technical approaches. Some have already reached scale. How do you think about today's competitive landscape?
I believe this year will be a watershed moment. I think 2025's commercialization is relatively false demand. But next year we'll see real ecosystems being established and real application scenarios taking shape. I think this will happen by the end of this year. So the 2025 landscape won't be very relevant for 2026 because the industry is progressing so fast. There are many new technical variables and they will cause a qualitative change between old product capabilities and new ones. So we don't pay much attention to previously successful dexterous hand companies or embodied AI companies and their impact on tomorrow, because the biggest variable in this industry is still technology, not things like market presence or supply chain or anything else.
Speaking of technology, with so many different technical approaches, do you think the direct drive approach we've chosen will become the widely recognized most promising approach with the most development potential this year and next year?
I believe this year will solidify the recognition that it has more potential, and next year it will turn that potential into reality.
What do you think Wuji Tech's long-term differentiation will be in this process? If direct drive becomes an industry consensus or an iterative trend, where's our differentiation and mode in the long term?
First, direct drive dexterous hand isn't that easy to do. You'll see many startups coincidentally choosing tendon-driven approaches. Even I alone at home cobbled together a tendon-driven solution. Because it's easier, you put the motors distally, and you can make it as big as you want, however you want, right? The only thing you need to solve is the tendon problem. But direct drive is a system-level solution. You can't make mistakes at any point. If one part isn't good enough, the whole system doesn't work. So it's a systems engineering challenge. It's not just about making good motors and then the direct drive solution is done. Every single element needs to be meticulously crafted. That's an R&D barrier. Second, I believe startup speed still matters. You need to move fast enough. We're currently advancing at rapid speed. Our organization is growing quickly, and our team's combat effectiveness and efficiency are improving in sync. I think that's the biggest moat for any startup.
Coming back to the industry landscape, there's one player that's hard to ignore, Tesla's Optimus. Elon has mentioned in many interviews that the dexterous hand is the hardest part of the entire humanoid robot project, consuming over 50% of engineering effort. They're also a company with strong systems capability, excellent engineers, and long-term resource commitment. How do you view their efforts on dexterous hand and their choices in approach and technology?
I feel Tesla attracts too much attention. I don't think what they've actually delivered matches the attention they get. As I mentioned before about the tendon-driven issues, they actually can't solve these problems either.
So the fundamental tendon-driven problems we've observed, Tesla hasn't come up with better solutions either, despite attracting so much attention and followers. Could this evolve into a trend where humanoid robot body manufacturers, because they have better control over the upper limbs and forearms, and because Tesla chose the tendon-driven route, would naturally lean toward tendon-driven? And for independent dexterous hand manufacturers, the direct drive approach would be a better choice. Eventually, the market splits into two technical routes, depending on the company's positioning.
Not really, because dexterous hand is too complex. Most companies don't have the capability to make dexterous hand well.
So you believe the eventual evolution of dexterous hand, due to their complexity and technical depth, will see highly concentrated leading companies empowering downstream humanoid robot body customers?
Yep.
This has actually happened in many industries, like lithography machines, right? When something becomes complex enough, previously chip manufacturers like Intel and IBM try to make their own lithography machines. Eventually, it inevitably becomes a third-party platformized outsourcing role.
Yep.
I'd like to discuss the choice of degrees of freedom. Wuji Tech's current generation product chose a 20 DOF solution. How was this number determined?
First, we wanted to make the degrees of freedom as high as possible. I generally agree that humans have 22 DOF. So where are the missing 2 DOF? First, your pinky can do a closing motion toward your palm, and second, your thumb's second joint can do a slight pressing motion. These two movements are really unimportant in our kinematic simulation. Without these 2 DOF, we can still perform all kinematic operations. That's why we gave up these 2 DOF. As for why we want as high DOF as possible, I often use hand models to pose different actions, and we found that if you're missing certain DOF, many movements look very unnatural, or operations I want to do simply can't be done.
So I understand we chose 20 DOF as an optimal choice, combining current engineering difficulty and product application scenarios. Will future iterations also follow this DOF?
I believe so.
When we talk about high DOF dexterous hand manipulation, how do you think control algorithms will evolve? We've seen early examples like OpenAI use shadow hand to solve the Rubik's Cube with very complex reinforcement learning policies. Do you expect that kind of approach to continue, or do you see a different direction emerging?
I'm a believer that large models can solve everything. With enough data, large models can enable a dexterous hand to do things even with zero shot. So I think all these tricks and constructs are insignificant in the face of massive amounts of data, just like OpenAI did around 2018. So I think this question really comes back to how you create the data.
So you just mentioned you're optimistic that large models can completely solve the manipulation problem. I understand you're referring to models and data related to hand manipulation and dexterous operation, right? Not the VLA concept many embodied AI companies talk about, like Pi, which is more task level, or higher level planning and thinking with relatively coarse manipulation.
No, I think it's a unified model. It should basically solve all problems. It's not some so-called manipulation small model or dexterous hand atomic skills small model. It's just one unified large model.
If we want to achieve a unified large model, it probably means feeding enough hand-related data into a unified architecture.
Exactly.
Today, because we don't yet have large-scale dexterous hand data, most VLA models are trained around 2 or 3 finger grippers. But looking ahead, once we have sufficient high-quality, high-efficiency, high-DOF dexterous hand data, do you believe we can feed that into a VLA model and move toward a single large model, possibly end-to-end, that directly outputs control signals from the torso all the way down to the arms, wrists, and finger joints?
Yep.
That's also a very ambitious goal. So by this standard, having the most efficient approach, similar to Tesla's shadow mode, to collect massive amounts of data during daily work and operations becomes a necessity.
Yep.
So will you collect this kind of operational data yourselves? Or is your thinking more about partnering with other AI labs or large model companies?
We won't collect this data for now, but we'll keep refining the data collection equipment until it's good enough.
Looking long term, will you train your own manipulation models? Will you be a pure hardware company or integrated hardware-software company?
For now, all our efforts are focused on making dexterous hand usable and selling better. We might train some simple models. The purpose of training models is mainly so we can run through the whole process and tell customers that at least our hardware works. We mostly hope our dexterous hand can serve our customers well, and they can build important results on that foundation.
So long term, is Wuji Tech positioned more as a core components company with dexterous hand as key parts, or do you aim to become a complete robotics company?
Our mission is to empower robots with human dexterity. It will solve what we consider the most difficult problems along this path. Today, we believe the biggest problems are hardware and data collection equipment, so we'll work hard to solve them. If our customers take our products and train an excellent model, there's no reason for us to do that ourselves. We just serve them well.
If in the short term we won't be involved in entire robot and model development, how do we ensure our Dexterous hand can adapt to different robot body companies and different model companies?
We're working on adapting to all humanoid-type robotic arms. We'll open source the adaptation results and publish the solutions on our GitHub. Our goal is to let customers get started quickly.
Isn't this a bit like Tesla publishing its charging solution, hoping all charging station companies or other EV companies follow their defined universal standard, or will you try to define an industry standard?
We believe standards aren't something you define. Actually, if your product is good enough, it becomes the industry standard. So it ultimately comes back to how do we make this product meet or exceed everyone's expectations.
Should interface include everything related to finger control and force control, including tactile and other sensors hardware and software interfaces? Because today there doesn't seem to be a unified standard that can uniformly define hand control and on-hand sensor information.
We'll have a standard SDK to provide these things, and customers just need to pull them from the host computer. We'll also create some examples showing how to run a very simple training process. We'll open source things like this. Then users can start quickly from what we provide and adapt it to what they want, fitting their algorithm training logic. That's what we see as our approach.
So whether it's the SDK or the interface, short term it's for better model training and testing, but long term it could enable more application developers to define their own scenarios and strategies. It might become a dexterous hand application ecosystem where you can download specific tasks. Yunzhe, who do you think Wuji Tech's most important high-volume target users are now and in the future?
So there will be 3 different development phases. In the short term, it's definitely research and model and algorithm companies. I believe 2026 will be the year of research, education, and algorithm company market. 2027 will be when we start penetrating industrial scenarios, and next 2 years we'll start penetrating consumer-grade markets.
Do you think industrial customers' pain points differ from research users?
I don't think there is much difference. Industrial users' characteristic now is that your robot isn't smart enough. If you can solve the intelligence problem, plus you have dexterous hand with the reliability a basic industrial product should have, then it should start scaling massively.
What does your current cost structure look like? Which part is the biggest cost driver? And long term, what level do you think an ideal dexterous hand cost could reach?
I think it will approach the price of a smartphone. I believe in the medium to long term, price won't be the limiting factor for dexterous hand. Intelligence will be the biggest limiting factor. Think about it, if you cut off your hand, how much would you be willing to pay for it, right? That price is really immeasurable. So a robot with intelligence and dexterous manipulation capabilities, once such a thing exists, especially early on, people will be willing to pay very high premiums for it. If it becomes a consumer-grade product, its price definitely won't be too high. The whole robot system will approach the price of a car or lower, and dexterous hand costs will definitely be very low, even lower than a smartphone.
Do you think there's a chance to get costs below $1,000 or even a few $100s?
I believe it's possible.
Yet, from first principles thinking, the ultimate cost would just be the marginal manufacturing cost of 20-some motors, structural parts, and gearboxes. There's another product definition question. Today, many industrial manipulation robots still use parallel grippers or 3-finger dexterous hand. Do you think this market will be one of long-term coexistence? Compared to existing grippers or 3-finger dexterous hand in the market, will industrial scenarios be a long-term coexistence relationship?
I think it depends on how you define coexistence. I believe in the long run, dexterous hand will be the mainstream market, because from a model training perspective, they're the mainstream. First of all, current 2-finger grippers don't have high intelligence, so there's really no market growth there. But if robots with dexterous hand have sufficient intelligence, which means the growth potential could be 100, 1,000, or even 10,000 times compared to today's gripper market and the future market that could be 10,000 times larger, the current market is insignificant. So from this angle, it's not coexistence. Dexterous hand will likely crush 2-finger grippers. But if you look at today's market landscape or next year's, 2-finger grippers and dexterous hand will definitely coexist, because dexterous hand haven't scaled up yet and haven't reached that intelligence level.
Okay, so let's talk about Wuji Tech's internationalization. Have you already started or have plans for large-scale overseas market expansion?
I'm currently expanding overseas.
What's the biggest challenge in this?
It's still about finding the right people. if we can find the right people overseas. For example, if you have a very strong person in any country who can handle things for you, then there's basically no problem.
Agree. Actually, there's no shortage of sales-driven today. Looking at overseas markets, or even globally, the early-stage research and exploratory demand is actually very strong. But whether we can deliver well and meet their needs is today's bottleneck.
Yep, we're not lacking leads, we're not lacking orders, but being able to convert well or serve them properly, that's actually challenging.
Yunzhe, there's actually an interesting detail here. I was the first investor to talk with you back in the second half of 2022. From a motor-focused company in 2022 to becoming a representative, Dexterous hand company in the industry today, I've seen so many changes over these 3 years. I'm really curious about your learning or iteration method. How can you enter directions and fields you may not have formerly encountered or tried before?
I think learning is really hard to summarize with methodology. Learning is inherently a very dynamic process. I think several things are very important. First, you need big enough ambitions. I often feel I'm not doing well enough. What's the gap between me and those top startups, or those in the best state? I even think every day about how to make my organization stronger, how to make the company more powerful. As for learning the professional aspects, I believe you need to have a goal. You need to know what kind of thing you want to create, then break it down. In this process, you'll encounter many problems. You need to mobilize all the resources you can to learn. I think this learning approach is very efficient.
Are you more of an inward learner or outward learner? When you encounter a problem, do you tend to take approaches like hands-on testing and experimentation, or do you extensively read and consult with industry experts or predecessors?
I think these two things can't be separated. You can't decouple them. Both are important. For example, when you take in external information, you must clearly distinguish what are their opinions versus what are facts. I'm very clear about understanding this. When I'm learning something from others, I pay close attention to one thing: the context. What's the environment? What are the experimental conditions? I dig very deep into this, then combine it with our own context and make adjustments.
You just mentioned setting very high standards or aligning with particularly excellent companies or entrepreneurs is a good learning goal. Have you had any senior entrepreneurs or mentors who had a big influence on you during your entrepreneurial journey?
Honestly, I don't really have someone I actually know in person who has given me especially big inspiration. That's actually quite rare because my starting point in early entrepreneurship was relatively low. I didn't have particularly strong connections or mentors.
In our previous conversations, I often heard you mention that DJI is a company you really admire and have learned a lot from. Have you had in-depth exchanges with people from DJI? Or are there specific practices you've learned from DJI that you're implementing at Wuji Tech?
I think where we align with DJI is that their spirit and culture are very close to ours. It's not that I deliberately learn from them. I naturally have this trait, and the organization we've built is the same way. When we talk with DJI people, we find, hey, we're like this too. We naturally became this way. I think an organization's shape is actually formed by the founder's personality and preferences. It's something that forms naturally.
How would you describe the distinctive culture or temperament of Wuji people?
Being able to understand the context of what you're doing well, and then being able to make, in this complex context, a decision that may not always be optimal, but is very good for the situation at hand. I think that's very important.
Speaking of Wuji people's traits, I've seen the company go from maybe 20, 30 people at the beginning of 2025 to 100, 200 people now in about a year. That's very fast team growth. What's driving this expansion, and how do you ensure that with such rapid expansion, your team and culture don't get diluted too much?
The biggest driver of this growth is real demand. As we reached this point, we found we needed this module or that module. The pain was so acute that without these modules, our company could be done for. So that forces us to fill in these modules. As for how to ensure organizational culture doesn't get diluted, I think when you have a good foundation and attract people through word of mouth, the organization naturally forms its culture. For example, when you have 4 or 5 excellent people and suddenly someone unsuitable appears, those people will naturally push out the unsuitable person. So it forms a natural positive cycle of culture. That's one thing. Another thing is that I think the founder's energy in shaping culture is still very important for companies under 1,000 people. You can perhaps strengthen culture through activities, cultural promotion, and operational work. But ultimately, what everyone watches is you, the founder, what you do every day in the company, the decisions you make every day. I think that's the most important point for ensuring you don't deviate from the main direction.
I understand you spend a lot of time on hiring and team building. Have you had experiences of hiring the wrong people?
Definitely, we've hired way too many wrong people.
How did you handle it?
I think a lot of times, if they don't fit, they'll realize it themselves. Probably at least 70% will leave on their own. For the remaining 30%, they're struggling. I'm struggling too. So I just have a conversation with them.
You'll proactively reach out to talk with them.
I'll talk to them.
My impression is that you have a very direct communication style in the company. People don't have to guess what you're thinking.
Yes, because actually my emotions and my feelings about people are very directly reflected in how I interact with them. So there's no need to guess at all. It's very obvious.
What's been your loneliest moment since you started the company?
I rarely think about these things. When I'm lonely, I don't think I'm so lonely, but rather, how do I solve this? What methods do I have to solve it? I immediately start thinking about solutions. There's no time to have any emotions or get emails or whatever. Once you've solved the problem, it's no longer important. If I do have emotions or feel anxious, I just pass it down directly. I'll say this thing is very important. We must take action immediately. And then everyone starts working on solving the problem. Generally, the results are pretty good.
Can you talk about Wuji Tech's fundraising experience? You actually didn't raise that much during the motor phase, and even after pivoting to Dexterous hand, you still didn't raise that much. Has the company experienced times of very tight cash?
I think our company has always been in a state of tight cash. We've never raised really big money historically. Making Dexterous hand actually requires more capital than we imagined. So we've always been operating with not so abundant resources. Actually, our company's fundraising, especially from 2024 to before the 2025 product launch, was never that smooth. People had doubts about us or were skeptical.
Was it external doubts or internal doubts?
There will definitely be both. External is just directly not investing in my team.
You had mentioned before that you achieved a better product with 1/10 of others' resources. How did you do that?
I think for things we should spend on, we're very willing to spend. But for things we shouldn't spend money on, we basically spend very little. Anyone who's been to our previous office would think our place was very bare bones, right? For expenses that don't help us get this thing done, I basically don't spend any money.
What's the next fundraising plan? If you had more resources, what would you want to do next?
I think the Dexterous hand supply chain is actually very long. The whole industry or equipment is heavier than I originally imagined. So we'll raise money to bring some key processes in-house. Also our data collection equipment. I think there are still many areas that need polishing, all requiring excellent people. So we'll further expand our organization's talent density and organizational capability.
If you were to summarize what you've learned from the past few years making Dexterous hand, what would be your biggest reflection since starting this?
I think not moving fast enough is a very fatal problem. Our pace of doing things early on wasn't fast enough. We were afraid to spend money. I think that's problematic. For a startup, I should have been as aggressive as possible in laying out our plans.
In a huge wave, you should be the fastest and most aggressive.
Should be extremely aggressive. Americans like to say YOLO, right? I think now should be a YOLO moment. The past 2 years should also have been a YOLO moment. But I think in our first year after raising funding, we actually weren't in a YOLO state.
So that's the biggest takeaway.
Yep, and also the biggest lesson.
When and how did you realize that you needed to YOLO?
Actually, it was in the second half of 2024 that we completely figured out how to scale Dexterous hand. When we figured that out, we felt we had to sprint at maximum speed.
Where do you think the most likely breakthrough in Dexterous hand technology will be in the next 2 to 3 years?
I think integration is the biggest breakthrough. There's no one of many. This is the breakthrough. We believe there are 3 things. First, hardware reliability and stability. Second, data. We are solving these first 2. The third is alignment, data generation, large data models, intelligence, and the alignment between human data and machines. I think this year we'll see a lot of alignment work emerge. We've solved hardware and data problems. Once the alignment problem is solved, intelligence will follow.
If everything goes well, looking 5 years into the future, what kind of company do you think Wuji Tech will become?
We believe we'll become a definer of intelligent agents. We'll define what form intelligent robot will take.
Alright, today's conversation has been very rich. Let me briefly summarize a few points that left a deep impression on me. First, the direct drive solution shows us the possibility of Dexterous hand achieving scale and widespread deployment, fully leveraging the advantages of manufacturing and scale. Second, Wuji Tech's refinement of core capabilities and technology in Dexterous hand left a deep impression on me. The company focuses on core technology breakthroughs with an extreme pursuit of product and technology excellence. Third, Dexterous hand are not just a hardware problem, but also an AI problem. The next 2 years are a critical moment. and we look forward to AI bringing major breakthroughs that will enable widespread adoption of dexterous hand applications. Finally, as the earliest investor to talk with Yunzhe, over 3 years have passed, and his growth and acceleration as a founder over the past 3 years is what gratifies me most. We look forward to Wuji Tech continuing to iterate and develop over the coming years, realizing the company's vision of dexterous hand replacing humans in all tasks. Thank you to Yunzhe for this wonderful sharing. This is the episode on dexterous hand co-produced by the Alphaist and Wuji's Talk. See you next time.